lesson, you are expected to identify a classification tree, follow a classification tree process flow, and appreciate the significance of a classification tree. So, we are going to talk about classification tree, which is actually a part of a decision tree, which is a recursive partitioning algorithm that follows a step-by-step process wherein we split or not split a certain node. So for more information about what I'm talking here, especially about the different parts of a decision tree, please go back to our lesson 1 for you to be able to properly understand this classification tree. So classification tree is actually a hierarchical Boolean question. There are binary responses for a certain decision to be made from the root node of our tree. So it could be a yes, it could be a no, it could be true, it could be false. So speaking of Boolean questions, there is always what we call a threshold. And this threshold dictates in what binary option a certain decision belongs. So a certain decision is xi, which is less than or equal to theta j. And theta j here is actually our threshold. So it can also be xi greater than theta j. It depends upon on a certain data science question at hand. Another thing that we have to think of a classification tree is that it is an ordered sequence of questions. So we have learned in our lesson 1 that our decision starts from the very root. And whatever decision that you take from this root, then you have to follow through until such time there is no more option left because you have reached the terminal node. And when you terminate at a certain point of your tree, then you have arrived at a certain predicted class. So for better understanding of a classification tree, let's have this very simple recursive partitioning of our tree. And in this case, we do have two input variables. We have x1 and we have x2. Of course, let's start from the very root and say, for example, we have the same problem as in our lesson number 1. Are we going to approve or reject a loan application? So here, on this side, we have yes, and on this side, we have no. So we're going to understand the different stages of our classification tree for us to be able to understand what goes on in each part of the stage until such time we have reached a certain decision of a certain class of our predicted value. So let's start first with our first step, and we're going to start from the very root, and we're going to ask this question: is x2 equal to or less than theta 1? And we have two options for this question. Is it yes? Does it comply with the condition? Or no? Does it not comply with the situation or condition? So if our answer is yes, then we have to follow this left side of our tree. And if our answer is no, of course we have to follow this part of our branch. So let's start first with the yes branch. And then again here, as you could see, we have two options. Is it yes or is it no? Of course, the first situation here is that does it comply with the situation? The answer is yes. And because we are already in this stage of our tree, we have another decision to be made. And the condition is this: is x1 less than or greater than theta 2? If we answer yes, then it means to say that it complies with this feature and it complies with this feature. So it means to say that T1, which is yes, is within the region of R1. Let me write here, R1, which is equal to x1 equal to or less than theta 2 and x2 equal or less than theta 1. So that is the region that corresponds to T1, which is yes. And of course, if our answer is no, that means it corresponds to the region, which is x1 is greater than theta 2 and x2 equal to or less than theta 1. If you are following through our discussion, then we could really see whether or not a certain branch follows a certain pattern or whether or not it complies with the different conditions. So these different conditions of each node would tell us the different features a certain terminal contains. So that means in the absence of one, the feature goes to the other daughter of our parent node. So let's go to this part of our branch. The answer here is no. And we can actually see that there are a lot of things going on in this part of our tree. So when our answer is no, that means it does not comply with this requirement, then we have to ask ourselves, is x2 equal to or less than theta 3? And again, we have here two options. We have yes or no. Let's follow the yes. That means it complies with this requirement, and this requirement becomes the feature of this node. And because it complies, then we have to go down and we have to answer the question, does it comply with x1, which is equal to or less than theta 4? If our answer is yes, then it becomes a part of our node T3. So what is then the region that can be found in T3? So here in our T3, we could see that it is the region in x1 equal to or less than theta 4 and x2 equal to or less than theta 3. And of course, if it is no, then it is the other way around, and it is x1 is greater than theta 4 and it is x2 equal to or less than theta 3. What about on the side of the no branch? So if we are going to take this decision, then you could see that we have no more options to think of because our terminal node can be found at this point in T5. So what is this region? This region is x2 is greater than theta 3. And of course, with respect to these different thetas and just these different regions, we have to think that we have made here our assumption that is theta 2 is less than theta 4 and theta 1 is less than theta 3. So as you notice, we have been discussing about the different regions, and each region of each of these 5 nodes represents its own class. So T1 is a different class, T2 is a different class, T3 is different, T4 is different, and also T5. So for example, with respect to whether or not granting or rejecting a certain loan application, then we can actually make a bracket. So for example, here we can grant a loan if a certain borrower has an income of 10 million. And here we cannot grant the loan application because our client or borrower has an income of 8 million. And here, although we have here no, we can still grant the loan application if the net asset of our borrower has a value of at least 10 million. And of course, no if the net asset has a value of 8 million. And of course, no here because the asset is just, say for example, 6 million. What is this for? Why do we have to study this? Having a profound understanding of the process flow of a classification tree will help you how to properly manage your decision in its every stage. After all being said and done, let's try this. What is a classification tree? Can you describe the process flow of a classification tree? Why do we have to understand a classification tree? Please write your answers in the comment down below so that we would be able to have a very rich interaction of ideas and we can learn from each other. Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free, like machine learning essentials, deep learning mathematics, and a lot more. Here, you can always learn an upskill for free.